What you see here is the control board of the Artillery Sidewinder X4 Plus. The main fault on this control board is the following. The microprocessor is unable to receive data from the NTC temperature sensor on the heater. The board has two NTC sockets labeled TB and TE. We're going to focus on these two sockets to resolve the issue. But first, let me briefly go over the other sections of the board. These four components here are the motor driver ICs for the axes. Aluminum heat sinks are mounted on them to dissipate heat. This is the Wi-Fi module that connects your printer to the outside world. Power supply voltage inputs, driver MOSFETs, voltage regulator ICs, and the regulator that supplies 3.3 volts to the STM32 processor. These here are the fan connector sockets. If your fans are running constantly or not running at all, you should check these components. The brain of the board is the STM32F402 microcontroller. Now that we've identified the components, let's move straight to taking measurements on the faulty sockets. I'm taking the measurements with a curve tracer, as usual. I'll start by measuring the black socket. The signal we see on this socket is a capacitor signal in parallel with a diode, meaning there's no issue here. Now I'm measuring the white socket. As you can see, the signal is completely different. This signal tells us there's a short circuit on this line. Normally, I should be seeing the exact same signal on both sockets. I'm flipping the board over right away. On the back, there are two TVS diodes connected in parallel with the sockets. Since they're connected in parallel, I naturally see the short circuit from the socket on the diodes as well. Now I'm setting the multimeter to diode mode and checking again. The readings on the good socket are normal. But on the faulty socket, we're getting a direct short circuit. So which component is actually faulty? Is it the TVS diodes or the Zener diodes on the other side of the board? The components you see here are 3.3 volt TVS diodes. Their job is to be connected in parallel on the line to protect the processor from external damage. Their primary purpose is to clamp voltage spikes and protect the sensitive microprocessor. The original TVS diodes are rated at 3.3 volts and are bidirectional, meaning they can be installed on the board in either direction. When these diodes fail, they typically go into a short circuit. This brings the voltage on the line down to zero, preventing the system, that is the NTC sensor, from reading any values. Now I'm going to desolder the diodes to determine which one has the short circuit. We can already tell from the symbol on the component that the diode is bidirectional. When I measure the TVS diode connected to the white socket, the component reads as a direct short circuit. I'm checking the other one. It's good. I'm confirming the measurement with the multimeter as well. The good diode showing open circuit is exactly what we'd expect. With the diodes removed, I'm measuring the sockets again. As you can see, the short circuit is gone. Both sockets are now giving the same signal. I'm moving right on to replacing the faulty diode. Before installing the new components, I'm cleaning the solder pads nicely. First, I'm soldering the good diode back in place. The faulty component was a bidirectional TVS diode, but I wasn't able to find the exact same part on the market. Instead, I'm going to use 3.3 volt unidirectional TVS diodes. To replicate the function of the original component, I'll be installing two directional diodes. These two diodes need to be connected in parallel but in opposite directions. If the diodes are placed so that their polarity markings face opposite directions, this configuration will block high voltage coming from either direction, functioning just like a bidirectional diode. If you can't find the original 3.3 volt bidirectional diode, you can use two SMP 3.3 unidirectional diodes in this manner. The replacement is done. Now I'm checking to see if the short circuit issue has been resolved. As you can see, the short circuit is completely gone. We're now getting the same signal on both sockets. If you enjoyed this video, don't forget to like it and subscribe to my channel. Also, make sure to share your questions or comments down below. See you in the next video. Take care.